Hello, I'm the Dr. Elizabeth Reynolds, and I were participant with Mr. Arthur Eddington's in solar observation project. Our primary goal in the research was to test Einstein's general relativity theory by studying the bending of light around the sun uh, during an eclipse to total to the sun. Our goal was to collect information, then analyze it to prove it or debunk Einstein claims or about the deflections of lights caused by the solar gravitational field. The mission occurred in the case of a total eclipse of May 20th, 1919. Two expeditions took place in two locations. One was located on the island of Principe, which is located in the coastline in Africa, in West Africa, and the other was located on Sobral, Brazil. These two locations offered the best opportunities to witness complete solar eclipse as well as gather necessary information. At that period, the plan was being developed by many important events were taking place in the globe. In 1919, World War One had been over. In addition, it was the time that the Treaty of Versailles was negotiated. Also in 1917, the Russian Revolution had also taken place in 1917 and led to the establishment of the Soviet Union. These global events set an environment of social and political shifts against which our research and development took place. The research team composed of physicists and astronomers, Mr. Arthur Eddington and a renowned British astrophysicist and astronomers commanded the expeditions and arranged the observations. He was associated together with the Frank Watson Dyson, the astronomer royal, who was provided the necessary support and resources. In addition, Eddington enlisted the help of local scientists and astronomers from the respective areas to help with the data collections and observations. Basically, my job was to be an assistant to the research team and a data analyst. I help with the calibration and preparation of the instruments that were used to take measurements. In the course of the solar eclipse, I assisted the recording. I assisted in the recording the positions as well as the brightnesses of the stars in a closer proximity to the sun, and carefully gathered the pertinent information. Following the trip, I took a part with the study of core of this data, making calculations on the analysis to access the degree of light deflector. Our work on the community of physics was huge. It results from Mr. Arthur Eddington. Solar eclipse observations provided substantial evidence for Einstein's theories of general relativity. The observed deflections of flights was in line with Einstein's equations and demonstrated the reliability of his groundbreaking theory. The confirmation of Einstein theories had far-reaching implications that established Einstein as a leading scientist and changing how we understand gravity as well as the structure of our universe. The acceptance of Einstein's general relativity theory was a major influence on the subsequent advances in science. It opened a new avenues for investigation and research in the field of cosmology and astrophysics. Scientists began to study potential implications of general relativity on our understanding of time, space, and the behavior of huge objects in the universe. The theory offered the framework to study gravitational waves, black hole formation, as well as the evolution in the universe itself. The modernization of cosmology, which includes that of the Big Bang theory, owes an enormous amount to the foundation that Einstein general relativity theory. Furthermore, the validation of this revolutionary theory has increased confidence in ability of mathematics and physical science to accurately explain the physical phenomena and forecast it. Enthralling many generations of scientists keep expanding the boundaries of our understanding. Thanks so much for listening.